Hurricanes and flooding have long caused pain and suffering to American families. In 2020, we saw the Category 4 Hurricane Laura cause nearly $9 billion in damage. And the prevalence of these hurricanes will become more and more of a reality as climate change increases with water levels and water temperatures, making more cities, and thus more people, susceptible to floods. What this means is that insurance companies will have to start offering flood insurance to areas where they have no prior data. This puts both the consumer and the insurance company in a bad spot. Since our team have members that have been affected by Hurricane Irma and Hurricane Sandy, this problem is one that's very close to our hearts. We wanted to build a solution that could provide resilience for citizens and better insurance tools for insurance companies when these devastating natural disasters occur. Introducing Noah's Ark.
Noah's Ark is a tool for homeowners and insurance folks to learn more about flood risks in different areas. This is powered by deep convolutional autoencoders that use prior hurricane image data to determine if a given region, in terms of latitude and longitude, has risk for flooding. So let's walk through the interface of our application. So immediately we're treated with the standard Google Maps application with buttons for map and satellite, which you can toggle and do some other things with. But the main aspect of our application itself is flood data. So let's look at some locations which give us some more insight into this. So for example, in the case of Florida, as soon as I click on Florida, you can see that there's an overlay over the map itself with a different kind of picture. This picture indicates flood risk based on our autoencoder. So the darker regions of this image indicate high flood regions, and the lighter pixels indicate less likely to flood. So as you can see, since this is a Florida coastline and Florida is regularly in the path of hurricanes every year, you can see the coastline has a lot of dark pixels indicating that there could be flooding. You can also see along the streets themselves that there are patches of darker areas, which indicate the streets and housing areas themselves could be flooded. So let's move to another location, for example, Texas. In the same case here. So as seen before with Hurricane Harvey in 2017, Houston, Texas is pretty prone to flooding. So as you can see with all these dark regions here. And similar to Florida, you can see all these paths along the different roads where there's darker pixels indicating flooding. You can also see on the top right corner a little indicator that says how dangerous it is for flooding. So in the case of Florida and Houston, it was pretty dangerous. But let's say we want to go to, Denver. So we can look at Denver, and as you can see, the image that is loaded is almost completely white with a few dark splotches here and there. But you can see that there's almost no risk at all. And this makes sense because Denver is such a high elevation that flooding is almost impossible to happen. We can also just freely move around in the map itself and toggle the flood map itself to get the flood map at the specific latitude longitude you're pointing at. So in this case here, again in Denver, almost everything is white, so there's very little risk. We can also toggle the weather map itself, and this will show us some of the data of the weather. So in the case of Florida, we have a pretty bad storm system coming this weekend, so you can see it right here. On top of the image data itself, we're also using elevation data to determine the risk here.
So this is a collection of the various frameworks and technologies we use to create this project. So the main foundation behind this was the Google Maps API. Besides the standard features that the Maps API provides, we added some extensions including weather data, elevation data, as well as a tool called geolocation, which allows us to get an address or a point on the map and get the specific longitude and latitude of that point. With that data, we can then pass that into our autoencoder. So our autoencoder, we're using a special type of autoencoder called a deep convolution autoencoder, which takes in an area, a satellite image of an area as input, and outputs that same area, but what it is predicted to look like if it were to get flooded. The way we did this is by training this autoencoder on public flood data from storms like Hurricane Harvey and Hurricane Irma. So now with that predicted flood map, we can then overlay that onto the original Google Maps, so you can see the difference in how an area looks like when it gets flooded. We also get all the data that we've collected and accumulated into a risk score, which lets you know how dangerous or how likely an area is to get severely damaged during a flood.
Noah's Ark is not only a way to help consumers determine flood risk, but more importantly can be used by insurance companies to view flood risk data on a large scale and generalize it to help improve the lives of people in communities that might need it the most now.